Designing a distributed key-value store at massive petabyte scale requires an architecture built around durability and strict consistency. Unlike systems that rely on eventual consistency, this design prioritizes data integrity and successful writes over maximum availability. Managing these priorities at scale is handled by decoupling the system into 4 distinct, specialized components. Separating data storage from cluster management allows the system to add capacity without compromising the accuracy of individual reads or writes. The process begins with request managers. These serve as the entry point for all client queries coming from the load balancer. Request managers cache cluster routing tables in their local memory, allowing them to locate data without the latency of an extra network jump. This mapping is dictated by the metadata manager, which routes keys A through L to group 1 and M through Z to group 2. To survive network splits, it uses a strict consensus protocol, blocking conflicting updates to maintain a unified map. Isolating metadata at the front end ensures that storage nodes are not consumed by the traffic required for network discovery. Replication groups store physical data across odd-numbered nodes, including 1 leader. To ensure strong consistency, all reads and writes route directly through this leader. It saves incoming writes to an append-only log, waiting for a majority quorum to acknowledge the change before confirming. Conflicts are resolved using a 16-byte sequencer. This unique, increasing number acts as a high-precision timestamp to determine the final state of the record. Using an elected leader and quorum acknowledgements prevents the data corruption associated with split-brain scenarios, even during node failures. System health is managed by the controller. It monitors nodes and automatically replaces failing hardware from a standby pool. When a table receives excessive traffic, the controller identifies the hot range, splitting the data to migrate a portion to a new replication group. During migration, the system performs a dual read, querying both old and new groups simultaneously to ensure consistency. This dynamic control plane presents the processing bottlenecks that typically limit the growth of static clusters. Funneling reads through leaders while separating cluster logic from storage creates the foundation for horizontal scaling. This architecture can support up to 10,000 replication groups, providing a total storage capacity of 50 petabytes. High-volume scale is achieved by enforcing strong consistency and automated load balancing across every transaction.